Welcome dear students, I am Raji Lohani and you are watching the topic capacitors and capacitance. On the previous day I told you the capacity of a capacitor, parallel plate capacitor, when there is no medium between its plates is given by C equal to epsilon 0 A upon D, where A is the area of each plate and D is the separation between them. If the space between the two plates is filled with a dielectric of constant K, then the new capacitance is Ck equal to epsilon A upon D, where epsilon is the permittivity of the new medium, which is equal to epsilon 0 into K. So it becomes Ck equal to epsilon 0 K into A upon D. I have already mentioned that the capacitance increases if there is a dielectric between the plates of the capacitor. How it happens, that I will explain to you later on. But before that, I would like to tell you the capacitance of a capacitor if the space between its plates is partially filled with a medium. Suppose we have a capacitor having the plates separated by distance D, and between these plates I keep a dielectric slab which has thickness T. Then we will have D minus T space without dielectric. The potential difference between the two plates now in this case will be the potential across the free space VO plus the potential across the dielectric slab, which will be different. But again we know that potential difference V equal to electric field multiplied by the distance. So it will become V equal to E0 into D minus T, because D minus T is the free space. So E0 is the electric field in the free space, plus Vk. Vk is Ek multiplied by T, where T is the thickness of the dielectric slab. So it is Ek into T. Again we know that electric field near a uniformly charged plate is given by sigma upon epsilon 0 or sigma upon epsilon. So in this case E0 will be sigma upon epsilon 0 and Ek will be sigma upon epsilon, where epsilon is the permittivity of this dielectric slab. So V is equal to sigma upon epsilon 0 into D minus T plus sigma upon epsilon into T, which can be written as sigma upon epsilon 0 into D minus T plus sigma upon epsilon 0 K into T. If I take sigma upon epsilon 0 common, then this expression for V becomes V equal to sigma upon epsilon 0 into D minus T plus T upon K. Remember, sigma is the surface charge density of each plate, which is Q upon A. So if I replace sigma by Q upon A, I get V is equal to Q upon A epsilon 0 into D minus T plus T upon K. This gives Q upon V equal to epsilon 0 A upon D minus T plus T upon K. but Q upon V is the new capacitance of the capacitor. So now the capacitance is C equal to epsilon 0 A upon D minus T plus T upon K. This is the general expression for the capacitance of a capacitor. Now, if we do not have any dielectric slab between the plates of the capacitor, then T will be 0. So, C becomes C equal to epsilon 0 A upon D, as has been discussed already. And if the whole space between the two plates is filled with the dielectric slab, then D will be equal to T or T will be equal to D. So the capacitance becomes epsilon 0 A upon D minus D plus D upon K. That is C equal to epsilon 0 A upon D into K. D and D will cancel, and this is the expression which I have already told you. Now question is, why the capacitance increases if the space between the plates of the capacitor is filled with a dielectric? For that, you will have to go back to what was called polarization of a dielectric medium. You know that if I have an electric field E, and in this field if I place a dielectric slab, then the dielectric slab will orient its molecules in such a way that the negative charge comes to this side and the positive charge comes to this side. That is, all the molecules of the dielectric slab will get polarized. The positive charge will be in the direction of the electric field and the negative will be opposite to it. As a result of this, if this dielectric slab is placed between the plates of a charged capacitor, then this will happen there too. It means if the electric field of the capacitor is this thing E, then an opposite electric field will be induced in the dielectric slab. This opposite electric field will cause the potential difference between the two plates to fall. If the potential difference falls, then by C equal to Q upon V, the capacitance increases. So what is basically the reason for increasing of the capacitance of a parallel plate capacitor when there is a medium between its plates is actually the polarization of the molecules of the given medium. To know more, continue watching. Thanks.